Hello and welcome to the United Learning Walking Talking mock. This video will go through paper 1 crossover questions for the November 21 series. On foundation tier papers, that's question 20 to 26 and it's worth 26 marks, and on the higher paper that's question 1 to 7 and it's also worth 26 marks. Okay, so question 20a, work out 3.67 times 4.2. Now, in order for us to work out this question, we are going to need to use long multiplication. And to make this easier, we're going to ignore the decimal points and we're just going to multiply it as if it was two whole numbers, 367 times 42. And when we finish the calculation, we'll add the decimal point back in. So to do this, we're going to need to do long multiplication. 367 times 42. 2 times 4 is 14. Write a 4, carry the 1. 2 times 6 is 12. Add the 1, that's 13. Carry the 1. And 2 times 3 is 6. Add the 1, which is 7. Now, as we move on to the next digit, the 4, and as that's the 10th digit, we're going to add a 0 here. So 4 times 7 is 28. So write 8 and carry the 2. 4 times 6 is 24. Add the 2, which is 26. So write the 6, carry the 2. And 4 times 3 is 12. Add the 2, which is 14. And to finish this off, we're going to need to add these two numbers. 4 plus 0, which is 4. 3 plus 8, which is 11. So write the 1, carry the 1. 7 plus 6 is 13. Add the 1 is 14. So write the 4, carry the 1. 1 add 4 is 5. And the last one, carry the 1 down. So I've got 15414. Now to add the decimal point back in, I'm going to look at my original question, and the numbers 4.2, that's to 1 decimal place, and 3.67, that's 2 decimal places. So altogether my answer is going to be to 3 decimal places. So 3 decimal places, that decimal point goes here. So 15.414. Of course, I didn't need to do that. I could have used estimation to find the magnitude of the number. So I could have rounded the 3.67 and 4.2 to both 4 times 4, and that would give me 16. So my answer needs to be in the magnitude of 16, and I could have done it that way to figure out where the decimal point goes. Question B, work out 59.84 divided by 1.6. Now, I don't find it helpful to divide by a decimal number. It's not really that easy. So what we're going to do is we're going to multiply both these numbers by 10 in order for me to make the number that I'm dividing by into a whole number. So that's going to be 598.4 divided by 16. And then I can use the bus stop method to divide this. So that would be 16 on the outside of the bus stop, 598.4 on the inside. Now of course I'm going to need to use my 16 times tables, so I might as well just write a few of those multiples down. So 16 is the first number in the 16 times tables, the next one is 32, and then 48, and then 64, and then 80, and then 96, and so on. And as I need more, I'll write a few more down. So I'll start by dividing 16 into 5. That doesn't work, so 16 into 59. Now 59 is bigger than 48, but it's less than 64, so that would be 3, so I can get 3 wholes. And then 59 to the difference between 48 and 59 is 11, so I'm going to write the remainder 11 on top over here. And now I'll move on to the next number. How many 16s go into 118? Now, as you can see, my times table doesn't go far enough, so I have to continue. And so 16 more than 96, that would be 112. And 16 more than 100, and that's 128. And okay, so how many 16s go into 118? That would be 1, 2, 3, 4, 5, 6, 7. And the difference between 118 and 112 is 6. I'm going to carry that decimal point up, and how many 16s go into 64? That's 4. So the answer to that is 37.4. Okay, so question 21 shows a Venn diagram, and we're told that the universal set, which is represented by this symbol here, has all the elements that are even numbers less than 19. So to begin, we're going to write down all the elements in this universal set which are even numbers less than 19. So 2, 4, 6, 8, 10, 12, 14, 16, and 18. If we move to the next line, we're told that in set A, we have these three elements, 6, 12, and 18. And in the next line, we're told that in set B, we have the four elements 2, 6, 14, and 18. Now you might have noticed that 6 and 18 appear in both sets, and with these numbers we need to make sure we write those two in the overlap between the two circles. So here we're going to write 16 in the overlap, and we're also going to write 18 in the overlap as they appear in both lists. And then we're going to write the rest of the numbers in each of these sets inside their respective circles. So in set A, we can see we've got 12 left. We're going to write 12 inside circle A, but not inside the overlap, as it doesn't appear in both lists. So 12 goes here. And likewise for set B, we've got 2 and 14 that needs to go into that circle B, but not in the overlap, because as it doesn't appear in set A. So we're going to write 2 and 14 over here. Now it might have looked like we finished this Venn diagram, however we can't ignore the universal set. The universal set tells us all the numbers that need to appear inside the Venn diagram, that includes inside the rectangle. So if we highlight or cross off the numbers that we've used already, we've got 6, well, in fact we've got 2, 6, 12, 14, and 18. So these are the numbers that we've used already from our universal set. But we still have 4, 8, 10, and 16 left over. So these don't appear in either of the sets, set A or set B, but they do need to appear in the Venn diagram. And so we're going to write these numbers on the outside of the circles, but inside the rectangles. So here 4, 8, 10, and 16, and that's it. That's complete. Okay, so question 22. Work out 4 1/5, take away 2 2/3. Give your answer as a mixed number. So the fractions in this question are already given as a mixed number. In order for us to calculate this, it's not going to be easy leaving the fractions as a mixed number. So what we're going to do is convert both of these fractions into an improper fraction, then find the lowest common multiple, find the equivalent fractions, do the subtraction, and then convert back into a mixed number. So to begin, what we're going to do is convert these two fractions into improper fractions. So to do that, we're going to multiply the whole number with the denominator and add the numerator. So 4 times 5 for the first fraction, 4 times 5 is 20, plus the 1 is 21 over 5. So 4 1/5 is equivalent to 21 over 5. And for the second fraction, we're going to multiply 2 with 3, that's 6, and add that on to the 2 in the numerator. So that gives us a numerator of 8 and a denominator of 3. And now at this point we're going to find the lowest common multiple between both of these denominators of 5 and 3. So the lowest common multiple is the smallest number in both of these times tables. So the smallest number in both the 5 and the 3 times tables, and that's 15. So what we're going to do next is scale this fraction, or both these fractions, to have a denominator of 15. So a fraction over 15, take away another fraction over 15. So that first fraction, I'm going to need to multiply both the denominator and numerator by 3. So 3 times 5 is 15, and so 23 times 21 is 63. For the second fraction, I'm going to need to multiply both the numerator and denominator by 5. So if I scale that up, 8 times 5 is 40. And now I can do the subtraction. So 63 take away 40 gives us 23 over 15. So this is the top heavy fraction. We need to convert this back into a mixed number, as the question wants the answer in as a mixed number. So to do that, I need to divide 23 by 15. So how many 15s go into 23? That's one whole, and then find the remainder of 8 and write that as a fraction over 15. So my answer is 1 and 8/15. Okay, so question 23. At the end of 2017, the value of Tamara's house was £220,000. The value of Rahim's house was £160,000. At the end of 2019, the value of Tamara's house had decreased by 20%. The value of Rahim's house had increased by 30%. At the end of 2019, whose house had the greater value? You must show how you get your answer. Okay, so this question is about percentages, more accurately percentage increase and decrease. And since this is the non-calculate paper, we are going to use a non-calculate method to solve this. So I'll start by working out the value of Tamara's house at the end of 2019. Her original value was £220,000, so we'll say that's 100%. Okay, and the value of her house decreases by 20% by the end of 2019. So that means we need to find 20% and then take it off the original 100% to give us an overall value of 80%. So to do that, I'm going to find 10% of the value of her house, and then I can double that to get 20%. So if I divide that by 10 to get 10%, I can then double that to get 20%. So 10% of 220,000 is 22,000, and doubling that will give us a value of 44,000. Okay, so then to find the overall 80% after the 20% decrease, we're going to do 220,000 take away 44,000. So we're going to do 220,000 take away 44,000. Now we can do this subtraction mentally. So 220,000 take away 40,000, that will give us 180,000, and then take off an extra 4,000, which gives us £176,000. So at the end of 2019, Tamara's house was worth £176,000. Then we can move on to Rahim's house. So that's Tamara. I can write Rahim here. So Rahim's house originally was worth £160,000. So the 100% value is £160,000. And then to find 10% of that, we need to divide by 10. And then to find 30%, we can times that by 3. So 10% of 160,000 is 16,000. And then to find 30%, we need to multiply that by 3. And that gives us a value of 48,000. And we know that the price increased by 30%, so we're going to add this on to add that 30% on to the original 100%. That gives us an overall value of 130%. So adding 160 onto 48, we can do that again mentally. So 160 or 160,000 plus 40,000, that gives us 200,000, and add on the extra 8,000, that gives us £208,000. So that's the value of Rahim's house at the end of 2019. So we can clearly see here that Raheem's house has a greater value. So to answer that question, we can just write Raheem's house has a greater value. So Raheem's house has a greater value, and that's the question done. Okay, so question 24, Rosie, Matilda and Ibrahim collect stickers. The number of stickers Rosie has to the ratio of number of stickers Matilda has to the ratio of number of stickers Ibrahim has is 4 to 7 to 15. Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? Now, to start this question, we're going to write this ratio in a format that's easier for us to recognize. So Rosie to Matilda to Ibrahim is in the ratio of 4 to 7 to 15. Now we're going to use a box diagram to solve this. So in order for us to draw the box diagram, I'm going to write R for Rosie on the side and draw 4 boxes that represent Rosie's share. I'm going to do the same for Matilda. So Matilda, draw 7 boxes that represent her share. That's 7. And lastly, draw 15 boxes for Ibrahim's share. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we can see from the diagram that Ibrahim has this many more shares than Matilda. In fact, we can see from the ratio itself that Ibrahim has 8 more shares. So this 8 is represented by these 8 boxes here extra that Ibrahim has, and that represents 24 shares or 24 stickers. So each share is worth 24 divided by 8. So if I do 24 divided by 8, that gives me 3. So each share is worth 3 stickers. I can write 3 for every box in the diagram, or I can just take each box to have 3 stickers in there. Now, to work out the total number of stickers that each person has, I can multiply the number of shares they have with 3, because there are 3 stickers in each share. So for Rosie, that would be 4 times 3, which is 12. So she has 12 stickers altogether because she has 3 stickers for each share. And for Ibrahim, that would be 15 times 3, because he's got 15 boxes, and in each sticker we've got in each box we've got 3 stickers, and that there is 45. So Ibrahim has 45 stickers in total, and Rosie has 12 stickers in total. To work out how many more stickers that Ibrahim has compared to Rosie, we're going to take the amount of stickers that Ibrahim has, which is 45, and find the difference with the amount of stickers that Rosie has, which is 12. So 45 take away 12, and that gives us an answer of 33. So Ibrahim has 33 more stickers. Than Rosie. Okay. Okay, question 25. The diagram shows a prism. The cross section of the prism is a right angled triangle. The base of the triangle has length 5 centimeters, and the prism has length 25 centimeters, and the prism has volume 750 centimeters cubed. Work out the height of the prism. So the first thing I'm going to do is highlight the cross section here's the right angle triangle, that's the cross section. There's two faces because it is a prism, and that means it has a uniform cross section running through it. We know that the length of the base is 5 centimeters. I'll highlight that on the diagram. We know that the length of the actual prism is 25 centimeters, and we know that the volume of the prism is 750 centimeters cubed, and we'll label that on the diagram. So V equals 750 centimeters cubed. Now, since this is a prism, to work out the volume of any prism, the formula is volume equals to the area of the cross section times by the length of the actual prism. Now, looking at this prism, we can see that the area of the cross section here is a triangle, and to work out the area, because we need the area of the cross section, to work out the area of this triangle, we need to use the formula area equals to base times height divided by 2. So I can rewrite that formula, volume equals to the base times height divided by 2 for that triangle, times by the length of the prism. So I'll just say L for the length. So now what I need to do is to find H, I need to substitute all the values that I have into that formula and then rearrange. So the values that I have at the moment, I've got the length of the prism, I can substitute that in. I've got the volume of the prism, I can substitute that in and swap that out. And I've got the base of the triangle, and I can substitute that out. So if I rewrite this formula again, I've got 750 equals to 5h over 2 times by 25. Now to solve it, I need to isolate h, so that means getting rid of everything on the right hand side of this equation. So to do that, I'm going to use inverse operations. Now it doesn't matter which order I take these in, as they're all multiplication and division on the right hand side. So I'm going to get rid of the multiplying 25 first, so I'm going to divide both sides by 25. When I do that, these two cancel out, so I'm left with 750 divided by 25 equals to 5h over 2. Now I can work this out, 750 divided by 25. I know that 10 lots of 25 is 250, and if I add another 10 lots of 25, I have another 250, and a third lot of 25, and that'll give me 250. So that means 3 lots of 25, or 250 is 750. So 25 times 30 equals 750, so that simplifies to 30. Now if I couldn't do that, if I didn't recognize that 250 goes into 750, or three 250s make up 750, I could have divided both the numerator and denominator by 5 twice in order for me to figure that out, and I would have ended up with 30 equals to 5h over 2. I'm going to continue solving, so I'm going to multiply both sides by 2, so I'm going to multiply the right hand side by 2, and I'm going to multiply the left hand side by 2. The dividing and multiplying 2 cancel out, so I'm left with 60 equals to 5h, and then I can divide both sides by 5. And I'm left with h equals to 12. So the height of that triangle is equal to 12, or the height of the prism is equal to 12. Okay, so question 26. The diagram shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. The surface area of the cube is equal to the surface area of the sphere. Show that x equals to square root of k pi, where k is an integer. That essentially means k is a whole number. Okay, so we need to show firstly that the surface area of, or we've been told that the surface area of the cube is equal to the surface area of the sphere. What we can start with is writing an expression for each of these two properties. So we can say the surface area of the square on each of the faces of this cube is x times x, because all the lengths around this cube are equal. So the area of each face is x squared. We also know that there's 6 faces on this cube, so we can say the surface area of the cube is equal to 6 lots of x squared, so 6x squared. The next thing we'll work out is the surface area of the sphere. Now we've been given a formula for the surface area of the sphere in the question. We know that it's 4 pi r squared, and we also know that the radius of the sphere is 3. So we're going to use this formula and the value of 3 for the radius to work out what the surface area of the sphere is. So the surface area of the sphere is equal to 4 pi r squared. We know r is 3, so it gives us 4 lots of pi 3 squared. 3 squared is 9, and 9 times 4 is 36, so that's 36 pi, and that's the surface area of the sphere. Now we've been told that both the surface areas of the two shapes are equal. Here, the surface area of the cube is equal to the surface area of the sphere. So what I can do is equate the two things together. So I can say that 6x squared equals to 36 pi, and now I can isolate for x, as I want to show that x equals to something root, x equals to root something pi here. So that wasn't a very good color to choose. Use orange instead here. So I'm going to need to isolate for x. So to do that, I'm going to divide both sides by 6. So I'm going to divide the left hand side by 6 and the right hand side by 6. That gives me x squared equals to 6 pi, and now I'm going to square root both sides. So if I square root the left hand side and I square root the right hand side, x squared square root is the square root of x squared is just x, and the square root of 6 pi just remains as the square root of 6 pi, and that's it. So k in this case is 6, and that's the question finished. Okay, so question 27. Freddie measured the length of a pencil as 7.2 centimeters, correct to 1 decimal place. Complete the error interval for the length p centimeters of the pencil. Now we've been told that the length has been rounded to 7.2 centimeters to 1 decimal place. Now when we round, we usually use the digit after the one we're rounding to help us round. So in this case it will be the digit after the 2. Now I've underlined the missing digit, and I'm going to put a placeholder there to represent it. Now to work out the upper and lower limit of this interval, I'm going to add 5 from those 2 digits, in this case 20. I'm going to add 5 and I'm going to take away 5 from that number. So the upper limit in this case is going to be 7.25, and the lower limit is going to be 7.15, and I can write that on the answer line. So the upper limit goes on the right hand side and the lower limit will go on the left hand side. And that's the question done. Okay, so question 28. The equation of a straight line L is y equals to 3 minus 4x. Write down the gradient of L. So we know from the question that we have a straight line, and the characteristic equation of a straight line is y equals to mx plus c. The gradient is represented by this letter M in front of the x. Now if we compare that to the equation that we have in the question, here we notice that it's written the other way around. So we can do this, the next step, one of two ways. We can either say, well, the coefficient of x in this equation is -4, so it's the number and the sign, so therefore the gradient is equal to -4, or we could have written this the other way around, so we can say, well, I'm going to make it look like this equation here, so I'm going to rewrite these terms. I'm going to put -4x at the front and +3 at the end, and then from there I can identify the gradient. So whichever way you identified it, the gradient m equals to -4. Part 2, write down the coordinates of the point where L crosses the y-axis. Where L crosses the y-axis, we're looking for the y-intercept. In this characteristic equation, C represents the y-intercept, and we notice that that value is 3. So if I were to draw a sketch of the graph, here's the x-axis and here's the y-axis, we know that this graph, because it's a negative gradient, I've drawn it with a downward slope, this y-intercept here is going to be 3. Now the question doesn't want just the y-intercept, it wants the coordinates of where it crosses the y-axis, or the coordinates of the y-intercept, and that there is on the point 0, 3, because it's 0 on the x-axis and 3 on the y-axis, so the coordinates there 0 and 3.